So mine's on the novel RT inhibitor to overcome the drug resistance of Selpercatinib. So first identifying the RT is arranged during transfection and is a receptor tyrosine kinase that is involved in cell proliferation, cell division, and survival, and initiates the mitogen activated protein kinase MAPK and protein kinase B ATK signaling pathways. RT mutations are involved with non-small cell lung cancer, NSCLC. The first generation drug is the Selpercatinib, which is FDA approved back in 2020. Is RET kinase inhibitor for the V804M gatekeeper mutation. My mutations were V738A and Y806C, which are secondary drug-resistant mutants, but have shown resistance to the first generation drug. So the 5 methods used were the database search, the protein structure properties, the homology modeling and guide docking, and virtual screening. I just talked about like briefly what goes on. And these were like the outputs. So these were the outputs for the database, the structural property, which is a 3D crystal structure of the RET. And figure 3 is a ligand for the V738A mutation. Continuing, this is the homology modeling and the glide docking, and the results of the docking concluded the two top compounds with a high docking score, indicating that they all had high affinity for the receptor, and the docking scores were negative 11.234 kcal per mole for the wild type. The top 10 compounds included the 5 top compounds from Zinc library, and the top 10 compounds were FDA approved. All 10 compounds were docked to the wild type and the 2 double mutants. The ligand with the most negative docking score was selected for both Zinc and the FDA approved drugs. The wild type was used as a reference, and no drugs were selected as prospect RT inhibitor. The V738A shows significantly better docking scores when compared to the first generation drug, the Selpercatinib. This was the virtual screen workflow, and the IC50 table, the Y806C and the V738B were selected, and the wild type is used as an absolute value 0, contributing to the G values of 0.52 for the Y806C and 61 for V738C. The G free binding energy from the docking scores was plotted against G for the IC50s and demonstrated a linear increase trend. Based on the IC value, is determined that there is a drug resistance on the mutant and the drug is potent. And the binding free energy demonstrating correlation between the docking score of the IC50s, the Y806C, V738A, and the wild type. So the research design was to find literature update from the structure analysis of the RET inhibitors. Next, perform molecular docking and results for the identification of the RET inhibitors, as well as their active structure, virtual screening, furthering the simulation on the compounds, and the free binding calculations were made in the Excel. Then perform a biological evaluation of the inhibitors and perform a manuscript preparation. The respective results for all the top 10 combination compounds were docked to the wild type, and the most negative docking scores were both from the Zinc and the FDA approved drugs. The docking scores were negative 11.234 kcal per mole for the wild type, and V804M and Y806C had the best docking scores of negative 11.48 kcal per mole and negative 8.381 kcal per mole. The Y806 and the V738A was a 29-fold IC50 increase, and the more negative docking scores have smaller IC50 values, which were the negative 11.489 kcal per mole. The lower IC50 values mean the drug is a lower concentration for the wild type and a higher concentration for the mutants. And these were my references.
TJ over there.
Damn. Just threw TJ.
I thought you did a good job.
Thank you. So that's great.
I don't have kind of either, but I like comment on the slide you show the validation. You see that linear part. It goes to that linear part. That's shows free energy. So you compare the table with that linear part. Which one is easy to interpret? Part, right? So that's the strategy. When then the table, those kind of data, you try to present into the figure, and we are the figure angle. So I like this one. Okay, good.